Hi guys, it's Miss Simon. I'm going to make this video today to help you guys out with science. So remember yesterday we learned about a scientist called Galileo, and he actually ended up proving Aristotle wrong. And we also learned kind of about how lighter objects take longer to fall than heavier objects, but it has nothing to do with the weight of the object. It has to do with the friction, the air resistance, okay? And we also learned that we saw yesterday that in space, when you take away the air, those objects end up falling at the same time. So today we're going to talk about a third and final scientist that has to do with gravity. And he kind of did the most with gravity, and his name is Sir Isaac Newton. So I'm going to share my screen here. Make sure if I highlight it, you put it down in your notes. All right, so go ahead, Sir Isaac Newton. So in 1687, Sir Isaac Newton published Principe, which explained nearly everything that had to do with moving objects, including gravity. Okay, Newton's work on gravity expanded upon the ideas and theories from Galileo's experiment. So basically what Newton did was he took where Galileo ended and just kept going with it. Okay, so he kind of agreed with Galileo, but he wanted to know a little bit more. So go ahead and add this into your notes, please. Newton's work on gravity expanded upon the ideas and theories from Galileo's experiment. And Newton is known a lot to do and to have done a lot of work with gravity. So again, he kind of took where Galileo left off and kept going. All right, moving on. So what was Newton's discovery? So I'm sure many of you have heard the story about this man who was sitting under a tree and an apple fell, and that's how gravity was discovered. Okay. While that might have been something that might have happened to Newton, okay, that's not really how gravity was discovered. Remember, we've learned that gravity has been around for millions and millions of years. Gravity was around for a long time before the apple fell on Newton's head. Okay. So what Newton actually did was apply mathematics to the falling apple and proved why objects fall down, okay? Because if we think of the apple doesn't fall to the left or fall to the right, okay? Everything falls down. And he applied mathematics to that and figured out why, okay? So rules of gravity. So what Newton did was apply mathematics to the falling apple, and that's why he proved objects fall in a straight line. So he was a very big mathematical person, okay? He took what was going on with gravity, what Galileo discovered, and he kept going with it by using math, okay? Another part you need to put down is he used mathematics to explain the world around him. That's what Newton did. He took math and he decided to use it to help explain what was happening. All right, moving on. So the gravitational forces on Earth pull any object near Earth's surface down towards Earth's center. Okay, so it doesn't matter where an object is falling, it's always going to be falling down. Okay, and you can kind of think of this very simply. Okay, say I have a pen, all right, and I drop it. Okay, it's going to go down. I can throw the pen to the left, but the pen is still going to fall down. So the thing is, Earth's gravity pulls everything down. Okay, that's the directions Earth's gravity pulls is down. So go ahead and put this in our notes, please. Earth gravitational pull. The gravitational forces on Earth pull any object near or on Earth's surface down towards Earth's center. So it doesn't matter how you throw something or where you drop something, it's always going to be pulled down to the center of the Earth. We can kind of see in this picture that all of these objects are being pulled down. All right, moving on. Okay, so obviously Newton, his main thing was about apples, but he went even farther than just that, okay? He made the very bold statement that the same gravitational force that attracted the apple to Earth also attracted the moon to Earth. So think about what we were talking about a couple days ago, where we were saying that why doesn't the moon fall into the Earth if everything is being pulled down to Earth? So let's see why. The moon actually is constantly falling towards the center of the Earth, but the moon is moving so fast in a direction perpendicular to the Earth that it moves in an ellipse around the Earth. So actually, guys, the moon is constantly falling towards Earth, but it's moving so fast that it doesn't have the ability to crash in and fall into Earth. Okay, so go ahead and put this down in our notes, delicate balance. The moon is constantly falling towards the center of the Earth, but the moon is moving so fast and perpendicular to the Earth that it moves in an ellipse around the Earth. So again, guys, the moon actually is constantly falling towards Earth, but it's moving so fast that it can't even fall into Earth, okay? Because as we know, the moon revolves around the Earth, and it's revolving so fast around the Earth that it doesn't have the ability to fall into Earth. All right, moving on. So we can kind of simulate this and think of it as if you tied a rope around a ball, okay? And you swung that rope around your head. Well, as you're swinging that rope, the ball is not going to fall and hit you, okay? And this we can compare to the moon's orbit around the Earth, okay? So if we attach it to a rope above our head, I'm pulling on the ball like gravity, but it's moving so fast when I'm swinging it that it's going to continue to go to a circle and it's not going to hit me. So I am Earth. The rope is standing for gravitational force pulling, and the ball is like the moon. Okay. So obviously, if gravity was not present, that ball, if that rope was not present, it's going to fly away. The ball is going to fly away. So the same thing would happen to the Earth. If the gravity of the Earth wasn't pulling on the moon would fly away from Earth and we wouldn't have the moon. All right, so let's answer these questions. Who explained gravity using specific mathematical language? So whose main thing was actually taking the information and applying math to it? Think of what we just talked about. If you said Newton, you are correct. Remember, he took Galileo's theories and kind of kept going, applying math to them. In which directions does Earth's gravitational force pull objects? Up and away, opposite of Earth's rotation, down towards the center of the Earth, or in the direction of Earth's rotation? Think about what we just talked about. The Earth is constantly pulling everything in what direction? If you said down towards the center of the Earth, you are correct. All right, guys, so that is where we are going to end for today. So I hope that this video was helpful, and I'll see you guys later. Bye.